All right, so my name is Jackie. I'm a software engineer from Snowtrail Computing. Today I will tell you about Snowtrail, which is a framework we use internally to test all aspects of our system. So this is joint work from with my colleagues Jin, Shrenik, Travis, and Allison. So first, a little bit a brief overview of Snowflake database. Snowflake is a cloud analytic database. It's built from scratch. It's multi-tenant, transactional, secure, scalable, and elastic. It's fully SQL compliant. It supports a relational model. We currently run on AWS and Azure. We currently serve over tens of millions of queries per day on top of hundreds of petabytes of compressed data. We have over 1,000 active customers, and we're growing very fast. So Snowflake's architecture is what we call multi-cluster shared data architecture. So there are three main layers. The bottom layer is the data storage layer, where we utilize AWS 3 or Azure Blob storage to store the data. The middle layer is the compute layer, which has abstractions called virtual warehouses, which are compute clusters which run SQL queries. And the top layer is what we call the cloud services layer, which contains things like the optimizer, transaction management, security, and metadata. So this separation gives us a very high elasticity in the cloud layer. It also gives us resource isolation in this layer. In the compute layer. In the cloud layer, having a unified metadata allows us to achieve multi-tenant very easily. Also, storing the data in the blob storage here gives us the time travel capability, where we can travel back in time to execute the query as of a particular point in time. So testing for a cloud database like Snowflake presents lots of new challenges as well as opportunities. So challenges are we have to be highly available. We're up 24/7. There's no downtime allowed. We adopt a very fast weekly online upgrade process. So we upgrade our software every week. And we have a huge size and variation in customer workloads, and it's very hard to exhaustively test for all these queries before we migrate our customers. On the other hand, there are lots of opportunities. We have the detailed information of every single customer query that's ever been run. We have the query tags, we have all their configurations, all their cloud settings. We have multi-tenant capacity, which means we can easily access customer schemas from a privileged role. So we also have resource isolation and elasticity. This means we can replay customer queries on a separate set of resources without impacting customers' production workloads. So our solution to solve this set of challenges, utilizing the opportunities, is a framework that we call Snowtrail. So Snowtrail internally has three main use cases in Snowflake. First one is in release testing. So this is integrated into our pre-release pipeline. So we have a weekly release pipeline, and before release, we run Snowtrail as the last step before we migrate customers to the new release. This achieves the effective coverage of customer workloads. And the second main use case is feature development. So we integrate Snowtrail as part of our feature development. So this enables what we call incremental feature development, which I will talk a little bit more about later. So this allows us to have an immediate understanding of the exact impact of Snowtrail on the system, because we can use Snowtrail to test on the exact customer queries that this feature is supposed to be useful for. Right? So the third use case is a sort of generic workload runner. For example, we use Snowtrail to warm up various caches in various layers of the system before migrating a customer to this new set of cloud instances. This avoids performance peaks during migration, so that the customer workload themselves do not actually have to warm up these caches themselves. We have these canary workloads that do that for us. It's also used for stress testing, and it's also used for capturing and replaying workload for POCs. So this diagram is a little bit complicated, but basically the dotted line is the workflow that's used by the developer, and the orange line is the flow of data in the Snowtrail system. So as you can see, all the data are stored back into the Snowflake database. So this includes the workload information, the statistics of the query that's run, the obfuscated results of the queries, and metadata of the Snowtrail runs. So developer starts by creating workloads. This can be done by either importing a workload or asking Snowtrail to select a set of workloads for them. After a workload is created, the developer can set up multiple runs. In this case, we show 2 runs, which is a baseline run and a target run using different settings. So after the runs are done, we have a verification process, and then we generate a report. So the Snowtrail runs are run on a configured cloud services on a dedicated virtual warehouse, which achieves resource isolation. So besides this, the developer can also choose to do customized analysis on these data because all the data are stored in the database in a relational format, so the developer can decide to join with multiple information that's stored in various tables and perform more detailed customized analysis. So Snowtrail workload is basically a set of queries with the configurations to run. A workload can be imported if the developer knows exactly what workload she wants to test. The workload can also be automatically selected by Snowtrail. As we mentioned, we run tens of millions of queries per day, so it's impossible to rerun everything. So we need a very good sampling mechanism. So the developer can specify a whole set of filtering criteria to narrow down the set of workloads that she wants to run. After that, we do heuristics-based filtering, such as query deduplication. Then we use a query-to-vac-based model to do further workload selection. So query-to-vac is a model that maps a query to a high-dimensional array, and by clustering queries in this vector space, we pick representative queries in each cluster so that we can achieve maximum coverage of the space. It's also integrated with usage tracking, which will be used for feature development. So to run the workload, we have several modes to run this workload. Right? So the normal mode is a batch mode, where basically user can specify a bunch of concurrency. Let's say I want to run the workload at 8 concurrent queries at a time, and other settings. There's also replay mode, which replays a captured customer workload as the exact time difference as the original workload. So this is able to capture a workload and replay the workload replay the impact of the workload on the load of the system, for example. So there's also an explain mode, which basically compiles the query. So this is used for testing the optimizer and issues in the compiler. There's also DML mode, which runs the DML, which essentially does a side effect-free DML. So it runs the DML, but does not have any impact to customer's actual table, but we use it to test the correctness of the DML statement. So to implement these runs, we have several mechanisms. So first one is to resolve obfuscation, because we do not want the developer to actually see the customer's data. So to do that, we add stable hash aggregation operators on top of the query plans for the queries that are run by Snowtrail. And these are stable hash aggregations, so they enable result comparison between queries, but at the same time, the results are not legible to the developer. We also have query direction and query completion context. Completion context is basically using a privileged row. During name resolution, we allow this row to resolve customer objects, because all our metadata is stored in the same layer. So this allows this privileged row to compile customer queries, essentially. We also have time travel, because to compare query results, we have to make sure that the queries are as of the same time, because the underlying table is constantly being changed. People ingest data into their table all the time. So time travel is needed to get a correct result comparison. So after the runs are finished, Snowtrail does analysis. There's 3 main categories of analysis. We look for new errors, crashes, and incidents. We look for wrong results, and we also look for performance regression. So before we generate this analysis, we need to skip the queries that cannot be used for the analysis. So queries can be skipped due to changes in the schema, because, for example, the query contains temporary tables and the session is dropped. It could be queries are non-deterministic. Actually, a large portion of queries are non-deterministic because they usually contain something like a current timestamp in their predicates, right? So there are lots of false positives in the performance regression as well, and these also need to be skipped. So to rule out the performance false positives, Snowtrail has an additional verification step. So there are lots of reasons for false positives. They could be due to variance in the cache states. They could be due to differences in the network latency. in the cloud environment, it could be due to the different concurrency that's currently running on that sort of set of resources. So during verification runs, we essentially replay the queries that Snowtrail thinks has requested in the same set of cloud configurations using a set of isolated resources. Right. So by replaying this multiple times, we're able to execute the query on a warm cache state, and we hopefully rule out all the intermittent issues that cause performance false positives. After that, we can perform result analysis. We generate a report that's reported the categories that we looked at in the last slide, and all the results are stored back into Snowflake and in a relational schema. Even after this, high false positive rates is still a major problem. So we have lots of wasted runs because we have to keep doing these verifications. Which is why we implemented a streaming mode. So the streaming mode is basically the developers specify streaming speed. Streaming speed is something like pick 200 queries every minute, basically. So that's the speed within which Snowtrail should run. And so this picks a macro batch of queries using the workload selector. The workload selector applies all these filters and selects these new macro batch of queries, adds to the queue, and then we decode the query, run it in many different settings, and the developer can pull the results as the workload is running. So this enables continuous runs of arbitrary duration because we can just specify the criteria of queries we want to run and just kick off the run and the speed of the run. So this means we can always pick up the latest customer queries, and it avoids falling off of time travel retention because we now run the query very close to when the queries are actually run. That also means we have fewer schema and data changes, and we can query the snapshot reports. So this figure on the right side shows that compared to batch runs, stream runs are able to achieve a much higher rate, much lower rate of false positives. So here is how we use Snowtrail for feature development inside Snowflake. So the developer starts with a quick prototype of the feature, implements usage tracking mechanism in the code to basically pick up to instrument which query can potentially use this feature, and wait for the code to be deployed. That's usually less than a week because we do a weekly online upgrade process. So after the code is deployed, the developer, so Snowtrail automatically constructs a workload based on the usage tracking information that the developer puts in the code. And once the workload is constructed, the Snowtrail can basically run the workload with the feature on and off. And after this, the developer can assess the impact on the real customer workload because this is the exact set of queries that once this feature is actually released will benefit. So the developer can actually assess the impact on this real workload and quickly iterate to make improvements, fix bugs, improve performances. We can also use it to determine whether something is even worth implementing to begin with. So we can implement a quick prototype and see if it will give us a very small amount of performance benefits. We don't even bother putting the effort into it. So to sum up, Snowtrail has greatly improved our release stability. It's changed how we develop new features. So we now develop features incrementally and test them on real customer workloads. It's made debugging in production much easier because we have all these mechanisms to replay a query as an exact setting, using the exact setting as the customer query. So on the other hand, so workload selection is a hard problem, as it turns out. And it's impossible to catch every issue before release, even for very extended runs of Snowtrail. So some mechanisms that rolls back the query to an old release version after the query fails on the new version is still needed. So some automation is still needed there. On the other hand, complex queries are very expensive to run, and there are lots of non-deterministic queries in the system. This leads to missing opportunities. So for example, one thing we can do is to implement a deterministic mode for non-deterministic functions, and we can use them for the Snowtrail testing. So there are lots of future work that can be done there. So with that, I'll take questions. Thank you.
Any questions? So maybe we kick start.
Yeah.
So So, nice presentation. So from a technical point of view, I totally see that makes sense and is very useful. So what we are currently seeing with the new EU data protection laws coming into place, that it's super hard to get customer workloads or even consent in order to do testing with customer data. Is this also something that you are already seeing, or is it not so much of a problem also in the US, or what's your take on that?
Right, so we also have internal discussions on GDPR, and we don't think it's a very major problem for us, because for us, our data are encrypted on REST. I think it's what GDPR focuses on. And for us, we have a web application, obviously, and all that. So we have also lots of other security-related features that we want to actually make sure that the developer can deduce nothing from the data. But obviously, the developer can see the plans, right? So you can still see, for example, cardinality of certain joins. I don't think that's easily solvable, and frankly, I don't think the people who write the GDPR law knows very much about these technical challenges. So yeah, that's my take on that. Yeah.
Great talk. Can we go back to the slide where we do the iteration? This one. You mentioned for code development, it takes about a week before that thing can actually be in your system and be tested. I'm a developer, I introduced a bug today, and that should take more than a couple of weeks to really come back and tell me, hey, I caused a regression.
Yes, so this is only for feature development and for prototype or ideas, right? So for bugs, Snowtrail has, we have implemented many features or mechanisms for Snowtrail that allows us to easily replay any individual queries. Right? So typically for bug fixing, what we do is we replay that individual query using the mechanism I described above, resolve application, directing a query to a particular set of cloud instances, setting up all configurations, and simply debug in production, if you will. Then that allows us to narrow down the problem to a very easily reproducible case, because sometimes the queries is so complex, it's very hard to get all the metadata from everything, download it, reproduce it in the local test deployment. But if you can directly simplify the query in production, then we can very easily download the part that's really required, then we can easily reproduce it. So that iteration is like less than a day. People can get it in a couple hours. When the bug hits, it's very, very fast. You can patch either the same day or the next day. So that's very fast. Obviously, if it hit a bug, we don't want to wait another week for it.
Thank you.
Yeah. Also, there are feature flags guarding the bug. So if you get if you hit a bug, you can also just turn off the feature.
Thanks.
Yeah.